Hello, and welcome to another video for Encouraging Engineering. Today, we're going to learn how to light an LED using a button. This is one of the simplest circuits to make, which makes it perfect for beginners. Before we begin, let's discuss the components we'll be using in this lesson. First, make sure you have an LED, a button, a 220 ohm resistor, some wires, a breadboard, and of course your Arduino. Before we start, we'll discuss some new components and how they work. An LED, short for light emitting diode, is a semiconductor that emits light when an electric current passes through. Notice how one of the LED's legs are longer than the other. The long leg is called the anode, and the short leg is called the cathode. It's important to know the difference for setting up your circuit. When using the LED, the cathode should be connected to the power in your circuit, and the anode leg should connect to the ground. This setup is important to ensure your LED works correctly. When using an LED, you'll need to use a resistor as well. For this project, we'll need a 220 ohm resistor, which can be identified by the colored bands on them. Resistors are important for preventing too much current in your project. Without the resistor, the LED could overcharge and break. However, there are various resistors with varying resistance. Using a resistor that's too high will prevent the project from getting the power it needs. Using a resistor that's too low could cause too much current to flow, potentially breaking your components. To know which resistor to use, you need to know Ohm's law. Ohm's law is a scientific principle describing the relationship between voltage, current, and resistance. The principle explains how voltage depends on the values of current and resistance, which are represented through the equation V equals IR. Alternatively, the equation can also be written as I equals V over R, or R equals V over I, depending on the value you need. In this case, we'll stick with R equals V over I since we need to find the resistance. First, we know the voltage is 5 volts since we're taking power from the Arduino board. For the current, you usually need a device called a multimeter, but to save time, we'll say it's 22 milliamps or 0.022 amps. Plug the values into the equation and you should get an answer around 227 ohms. When looking at our resistors, the closest value would be the 220 ohm resistor, so that's the component we'll use for this project. To save time in future projects, you'll be told which resistor to use, but make sure to know Ohm's law for future reference. Now that we know the components, let's set up our circuit to start coding. Feel free to pause the video and copy the circuit on screen. As you go through these lessons, we'll explain the process of coding and learn some of the basics together. I recommend following along to understand coding concepts for future projects. To start, let's set up some variables. Variables are lines of code used to store data, which can be letters, words, or numbers. In this case, we're using variables to represent numbers corresponding to pins on the Arduino. If you copied the circuit setup from before, you'll notice that the number we chose for the LED pin variable is 6, which corresponds to the pin 6 on the Arduino, which we connected the LED to. The other variable, button pin, corresponds to the button component we'll be using to turn on the LED. If you changed the circuit setup from before, make sure to label the variables correctly. As a side note, make sure to know what a comment is and how to make one. These are notes you can put into the program, usually for future reference or communicating with other programmers. If set up right, your program will look over the comment, preventing it from messing with your work. If it's not set up right, you'll have errors in your code. Different programming languages have different comment formats, but for Arduino, you either do 2 dashes or a dash asterisk and asterisk dash. Some examples are on the screen here. Next, let's look at the setup function underneath. A function is used to store parts of code that can be called any time in the program. Arduino uses thousands of special functions in its programming language, including setup, which is referenced and called once at the start of the program. As its name suggests, it sets up some parameters before the next section of code starts. Within the setup function, we're going to be using a function called pin mode. This function will configure the components to the Arduino pins they're connected to. In the parentheses, it should include the pin where the component is connected and whether it will be treated as an input or output. If the component will take in data to influence another component, it will be an input. If the component is influenced by a different component, it will be an output. In this case, the LED will be an output since it depends on the button, and the button is an input since it will influence the LED. Also notice that we referenced the LED pin and button pin variables to represent the pins. Again, make sure these correspond to the correct pins to prevent any errors. Now that you've finished the setup function, let's move on to the loop function. As the name implies, this function will loop repeatedly during your program until the Arduino is turned off. This is where the main section of your code will be written. Within the loop, we're going to use an if-else statement. In programming, we use the if-else statement when we want two or more different things to happen in our code based on different conditions. In this case, we want the LED to turn on when the button is pressed, but we want it to turn off when the button isn't pressed. Let's walk through how to show this in our conditional. For our first condition, we want to check if the button is turned on. To do this, we'll need the digital read function. This will have the Arduino check the component to see if it's turned on or off. The component you want to check should be in the parentheses here. To check if it's turned on, we'll say to check if the component reads high. In Arduino, high means there is voltage and something is turned on. Alternatively, low can be used to check if there is no voltage and the component should be turned off. Also, make sure to use double equal signs here, not a single equal sign. We only use one equal sign to create a variable. Under the first condition, we're going to program our LED to turn on by instructing the Arduino to send power. We can do this by using the digital write function, which is used to turn a component on or off. It's important to know that digital read will check if something is turned on or off, and digital write will make something turn on or off. In the parentheses, put the component you want to manipulate, in this case the LED, and whether you want to turn it on or off. To turn it on, we'll put high so the Arduino sends voltage to the component. Under the else condition, we need to put what will happen if the button isn't pressed. All we need to do is put another digital write function, but this time we'll set the LED pin to low. This will stop voltage from coming to the pin, turning off the LED component in the process. After you finish the loop function, either plug in your Arduino or start your simulator to test if it worked. Your LED should be turning on and off as you use the button. If nothing happens or works incorrectly, here are some ideas to troubleshoot the issue. First, check that your code and circuit setup are correct. If you got an error message from the Arduino IDE, it should highlight and mention the line where the error occurs. You can also double check that the right pins are referenced for the components. Finally, make sure the cathode and anode legs of the LED are set up right. Remember, the cathode should correspond to the power, and the anode should correspond to the ground. If you still face issues, take a break from your project. and return to it later. You'll be surprised how effective this can be. Before we end, I'd also like to recommend some extension ideas to practice more. Each video, I'll offer some ideas for advanced projects so you can practice what you've learned and understand Arduino better. For this lesson, I recommend projects like using more than one set of an LED and button, having one button turn on more than one LED, and making an LED blink repeatedly when a button is pressed. Again, all of these ideas are possible based on the concepts you just learned today. I hope this lesson was useful, and I encourage you to keep exploring more on your own. Thank you for watching.